Let's explore some foundational concepts in data modeling that are crucial for anyone in the business field: entities, attributes, relationships, and keys. First off, an entity is basically a thing or object within a business context. Think of entities as the nouns in our data model. For example, in a retail business, entities could be customer or product. Next, we have attributes, which are the properties or characteristics of those entities. If we're talking about a customer entity, attributes might include the customer's name, address, or email. For a product entity, attributes could be the product price, description, or stock quantity. Then we have relationships, which describe how entities interact with each other. For instance, customers place orders or products are supplied by vendors. Understanding these relationships helps us map out how different parts of the business connect. Lastly, we have keys. Keys are unique identifiers or links between entities that ensure data integrity and allow efficient access to data. They play a crucial role in our data models by uniquely identifying records and establishing relationships between tables. Now, let's delve into the different types of keys you'll encounter in data modeling: primary key, foreign key, composite key, surrogate key, alternate key. Each of these keys serves a specific purpose in organizing and accessing data within a database. Understanding how and when to use them is essential for creating efficient and reliable data models. Let's start with the most fundamental keys: primary keys and foreign keys. A primary key is a unique identifier for each record in a table. Think of it as a way to ensure that every row in your table is distinct. For example, in a customer table, the customer ID would serve as the primary key because it uniquely identifies each customer. A foreign key, on the other hand, is used to link records in one table to records in another. It's essentially a reference to a primary key in another table. For instance, the customer ID in an orders table serves as a foreign key that links each order back to the corresponding customer in the customer table. This connection allows us to see which customer placed which order. Next up is the composite key. This is a primary key composed of two or more attributes that together uniquely identify a record. Let's consider a university system that tracks course enrollments. Here, we have a many-to-many relationship. Each student can enroll in multiple courses, and each course can have multiple students. To uniquely identify each enrollment record, we combine the student ID and the course ID. Neither of these alone is sufficient to uniquely identify a record, but together they form a composite key. The combination of student ID and course ID uniquely identifies each enrollment. Now let's talk about the candidate key. These are attributes that could serve as a primary key because they can uniquely identify each record. Imagine we're managing employee records in a human resources system. Our employee table might include employee ID, an internal system-generated unique identifier; Social Security number, a government-issued unique identifier. Both of these are candidate keys because they can uniquely identify an employee. However, we need to choose one as the primary key. Typically, we'd select the employee ID as the primary key to avoid using sensitive personal information like Social Security numbers. Here, employee ID is chosen as the primary key, while Social Security number remains a candidate or alternate key. Moving on to the surrogate key. This is a system-generated unique identifier, often an auto-incrementing number, used when no natural primary key exists or when using a natural key is impractical. Consider an e-commerce database that stores orders. While we might have natural keys like customer ID and order date, they might not guarantee uniqueness due to the possibility of a customer placing multiple orders on the same date. To solve this, we introduce a surrogate key called order ID. This is an auto-incrementing number that ensures each order record is unique. Using a surrogate key simplifies relationships between tables and helps maintain data integrity, especially in large databases. An alternate key is a candidate key that wasn't selected as the primary key, but can still uniquely identify records and is often used for lookups. Let's say we're managing a product inventory system. Our product table includes a product ID, which is a system-generated identifier chosen as the primary key, an SKU, or stock keeping unit, a unique code used for tracking inventory. While product ID is the primary key, the SKU serves as an alternate key. It's useful for searching products or integrating with external systems that recognize the SKU. Even though SKU isn't the primary key, it remains a crucial attribute for inventory management. To wrap things up, here's a quick summary of when to use each type of key. Composite keys are used when two or more attributes together uniquely identify a record, such as in an enrollment table where both student ID and course ID are needed. Candidate keys are used when multiple attributes could serve as a primary key. You'll choose one as the primary key and others become alternate keys. Surrogate keys can be used when there's no natural primary key, or when you prefer a simple system-generated identifier for uniqueness, like an auto-incrementing order ID. Alternate keys are candidate keys chosen as the primary key, but still useful for searches and ensuring data integrity. Understanding these key types is essential for designing effective data models that maintain data integrity and support efficient data retrieval.